Hello, Nicole Mashburn here, and today we're going to talk about the skin, also known as the integumentary system. Okay, so what I want to do today is talk about the skin, its functions, and its basic anatomy, and then we'll have some other videos with more details. So the first thing I want to talk about are the functions of the skin. The first function is protection. Okay, and when we think about protection, literally the skin protects us from the outside world. And it does that in three ways. There's a chemical layer of protection, a physical layer of protection, and a biological layer of protection. And what I mean by that is our skin secretes secretions that are acid, makes an acid mantle that basically stops bacteria from growing. It's almost like using a hand gel. So your skin is got a secretion that will kill bacteria. You have your physical barriers. And mechanical barriers. And so one of the things that your skin does is it makes keratin and a glycolipid. Keratin is kind of a waxy substance that kind of waterproofs your skin. It allows you to hold water into your body and then also not to allow water into your body, or allows you to hold water into your body so it doesn't go out, and allows outside water not to come in. So it's a barrier, a physical barrier to water. Now things can cross it because it's made of lipids. Anything that's fat soluble can actually go through the skin. So if something is lipid soluble or fat soluble, like poison ivy or some organic compounds, think about like a paint thinner, things like that, heavy metals and drugs, those can go through the skin. That's why some drugs, they're going to be embedded into a lotion. So if you're going to use, there's a testosterone medicine that they'll put in a lotion, or some of your drug patches, things that will allow the drugs to be lipid soluble can then go through your skin when you're wearing these patches and things like that. It's also why when you use lotion, lotion's fat-based so that it will be absorbed and it actually helps to soften your skin. And you have some cells. You have dendritic cells and macrophages, and even your DNA are biologic barriers to things. So we've talked about macrophages before, your big eaters. So if something gets in your skin, your macrophages can come and like Pac-Man, and take those out. The skin also helps you regulate your body temperature. And so we know that when you're hot, you sweat. And so as you sweat, that allows the heat to be radiated away. And so every day you're going to lose about a half a liter of water just because you're constantly sweating. You just don't even notice it. And so at normal body temperature, it's called insensible perspiration. But we all know as temperature goes up and your body temperature goes up, then you'll send more blood to your surface and you'll sweat more, you'll lose more fluid. On the flip side, if you're cold, you can actually shunt blood away from your skin and kind of keep that heat in your core. So we do use our skin as a way of regulating our temperature. We also use it to allow us to know what's going on in the world around us. We have what are called cutaneous sensations. And we say cutaneous, that means skin. So we have temperature receptors, touch receptors, pain receptors that allow us to know about our environment. The skin has some metabolic functions. There are things that you need to produce in your own body that they start in the skin, like collagenase. Vitamin D is one that most people know about. The skin doesn't make the vitamin D, but it starts the process. So the skin, when you have UV radiation or sunlight, causes the skin to start the process of making vitamin D. And vitamin D is something that we need in order to absorb calcium. So you need calcium for strong bones. So one of the ways you can increase your bone strength is to make sure you have enough sunlight to make that vitamin D to help you absorb calcium in your small intestine. The skin can also convert some things like carcinogens and hormones, and some of these are going to come up as we move along in our discussions. We also use the blood as a blood reservoir, so we store blood there. About 5% of your blood volume is in your skin. It's also part of your excretory system. We get rid of waste there, specifically nitrogenous and salt. So nitrogenous waste and salt can be gotten rid of, especially salt in your sweat is one way we can get rid of things. So let's talk about the anatomy a little bit. And so when we think about the skin, it has three layers. It has an epidermis, a dermis, and a hypodermis. And the epidermis is the part that you see. It's the superficial region. And then just deep to that is the dermis, and then deep to that is the hypodermis, which is also known as the subcutaneous layer. And it's also mostly fat. Technically, it's not skin, so it's subcutaneous. So cutaneous means skin, so it's below the skin. So this picture is in your book, and so as we move through the skin slides, and also you have a skin lab, you can keep referring to this particular picture, because when I say things you can go back and go, okay, I can find it on this slide and see it. I'm not going to make a copy of this slide for every slide that you see. You'll see it a couple more times, but again, use this as kind of a reference slide. So here is your epidermis, this brown layer, and then your pink layer is your dermis, and then the yellow layer below that is your hypodermis or subcutaneous layer. And you can see the epidermis, there's not a whole lot going on there. The dermis, you have hair, you actually have some little muscles that we're going to talk about, you have nerve endings, you have some blood supply, you've got some glands, and then the hypodermis is mostly just fat and blood vessels. And again, we're going to go through each one of these layers and talk about specifically what you expect to find and what they do. Now, I don't want you to think of things only in terms of models, okay? You also need to think about histology, because we've just covered histology. We've just finished talking about the tissues. So I want to start making sure you're making those connections between what you learned in tissues and what you're learning now. So the epidermis is actually stratified squamous epithelium, so multi-layers of those flat cells. The dermis is irregular or dense irregular connective tissue. Okay, so this is that type of connective tissue that's kind of randomly designed. Okay, so you can move your face in many directions. Your skin's real pliable. The dermis also has glandular epithelium. So if you think back to the first unit on tissues, and we talked about epithelial, you have glandular, you have exocrine and endocrine. Well, in the skin, you have exocrine. So that's the stuff, that's the glands that send things through a duct, like sweat and oil. And then the hypodermis is adipose tissue. So what type of tissue is adipose? It's an example of what type? Connective tissue. Okay, so we have an example of epithelial tissue and stratified squamous, also your glandular epithelium, and then your dense irregular connective tissue and adipose connective tissue. So start making these connections. We need to start tying, as we move forward, we want to tie what we've learned previously to what we're learning now. Can't just learn it and dump it. Okay, so the epidermis, it's avascular. That means it has no blood vessels. It doesn't have its own blood supply. It's stratified squamous epithelium. That means it's got many, many layers of flat cells. So this whole thing, this pink to brown, is the epidermis. And this epidermis is actually made up of 4 to 5 layers depending on what type of skin it is. And this epidermis, the skin is keratinized. Again, that's that waxy protein that kind of makes our skin waterproof. Some of the cells that you expect to find in the epidermis are your keratinocytes. They make the keratin. Melanocytes, they make melanin. And that gives your skin its color. And we'll talk more about that later on. Macrophages, which are part of the immune system, some tactile cells for touch, and the epidermis is going to be thicker on the soles and the palms than the rest of the skin. So remember, stratified squamous is good for abrasion, so where you would need more protection on your feet and hands, you're going to have thicker epidermis. So I've got a picture of that to show you. This is thick skin. So again, that's the epidermis, and you have a really, really thick outer layer, again, to help protect you from abrasion. Whereas thick skin has a very thin epidermis. Okay, so thin skin is thin epidermis, thick skin has a thick layer. And you'll see this again when we talk about this on your skin lab video. So when we look at the epidermis, it's actually divided into layers or stratum. And depending on where the skin is, it has 4 to 5 layers. This particular slide has 4. I'm going to talk about all 5 as I move along. And we use the word stratum to mean layer. So there's a stratum corneum, a stratum granulosum, a stratum spinosum, and a stratum basale. And there's also a stratum lucidum, which I'll talk about that in just a second. Stratum lucidum. And so the stratum corneum is your most superficial. That's what you see. And it's about 20 or 30 layers of dead cells. Okay? And this is that waterproof layer, and helps you fight off abrasion. Then you have your stratum granulosum. And this 3 to 5 layers, and this is where you actually have these granules. So the cytoplasm is full of granules, and it looks real grainy when you look at it under the microscope. You have the stratum spinosum, and it's just a few layers. And then you have your stratum basale, and it's the base layer, okay? And it's just one row of mitotically active cells. So we're going to go through each one of these and give you a little more information about them. So here's your dermis. That's the deep layer. You have one layer of your skin cells, your epidermis cells, that are actually growing. And as these cells grow, they migrate kind of up and out. And this is what you slough off, okay? So when you scratch your skin, this last layer is what is kind of sloughing off when you scratch your skin. So that basal layer, that's the deepest epidermal layer, and it's attached to the dermis. That's what's connecting the epidermis and the dermis. A single row of actively dividing cells, and they divide really quickly, and it takes about 25 to 45 days for those cells to migrate from the base layer all the way out to the surface. The stratum spinosum is known as the prickly layer, and that's just an artifact when you take the skin and put it under a microscope. The little desmosomes that are kind of connecting those cells together, they make this little prickly formation. So again, that doesn't really look like that in real life, but under the microscope it does. So it's the spiny layer. And this is where you have the RNA that helps you synthesize keratin, which is a protein. So we talked about protein synthesis, and so this is where that occurs. Lots of melanin granules are being made here by the melanocytes. And melanin, again, that's what gives your skin its color, but actually its function is to act as a sunscreen for DNA. So if you think about a cell, okay, and here's the nucleus, which is where the DNA is. So here's my sun, and the sun's beating down with the UV radiation. Melanin will actually kind of orient itself over the nucleus, kind of like an umbrella. So the darker the melanin, the more protective it is. That's why if you have light skin, you have a light-colored melanin, and you're more prone to have things like skin cancer because you don't have that dark melanin acting as an umbrella to protect your DNA. And we'll talk more about that as we go on. Your stratum granulosum, it's a thin layer, 3 to 5 layers. This is where your granules accumulate, and your cells are fully keratinized, so they're waxy and waterproof at this point. The stratum lucidum, you only see this in thick skin, okay? So you don't see this in the thin skin. So this is that extra layer that you only find in the thick skin. And it's just really, really thin. Lucid means clear. Okay, that's what, so if you ask someone who maybe has had confusion, you go, hey, are they lucid? That means, are they clear? Okay, so that's what that word means. So the stratum lucidum is the clear layer. And so it's transparent. So when you look at a slide, it looks like a space or a gap because it is transparent. And this is just a few rows of dead flat keratinocytes that you'll see in the thick skin. And then the last layer, the superficial, the one you see, the stratum corneum, that's the horny layer, okay? And this is 20 to 30 layers. This is most of the epidermal thickness, okay? So 3/4 of your thickness of your epidermis is this last layer. And this is what determines thin or thick skin. So obviously a thin layer would just have, maybe 10 to 15 layers of keratinized stratified squamous epithelia cells, and thick would be even thicker. Okay, so the more layers you have, the more protection you have. So this layer is protection from abrasion and penetration. It's the waterproof layer, and it's the layer that you have your biological, chemical, and physical assault. Okay, so it's kind of your first form of protection from the outside world. Everything's got to get through that horny layer before it gets to the layers below and then down into your dermal layer. Which brings me to the dermis. So the dermis is that middle layer, just deep to the epidermis. It's really strong, okay? And it's also very flexible because it has that dense irregular tissue. The cells that it has, this should go down actually, my slide's messed up. The cells that you find in the dermis will be fibroblasts, so that makes fiber, so kind of gives it structure. Macrophages for immunity. And you're also going to see some mast cells and white blood cells. Mast cells make histamine, so if you touch something that makes you itch, that's because those mast cells make that histamine. So you take an antihistamine to quit itching. And then white blood cells are in there trying to fight off any kind of things that may invade your skin. Your dermis also has blood vessels. It has nerve processes. You have glands in your dermis. You have your hair follicles are in your dermis. And the dermis is made up of 2 layers. You have a papillary and a reticular layer. So the papillary layer is this layer here, kind of does like that. And the reticular layer is everything deep to that. Okay, that's your 2 layers of the dermis. Again, you'll see this again in your skin lab video. So when you look at the dermis, it's very dense, irregular connective tissue. That's all of this. What you're seeing is dense, irregular connective tissue. And you have your papillary layer, okay, which is what's in contact with the epidermis. And it's what binds the epidermis to the dermis. But most of your dermis is this reticular layer, which has a lot of elastic fibers and also collagen fibers. So it's strong but also bendy, okay, so it can stretch and move. And then again, just to reiterate, the bottom layer, your hypodermis, this is mostly fat. And so what you're seeing here, all this is adipose tissue. I think it looks like bubble wrap. So if you see anything that looks like bubble wrap, that's adipose, and you're in the hypodermis. So things that you can find in the dermis, a lot of receptors, a lot of your receptors, your Pacinian, and some people say Patinian because it's Italian, so either one. These are your pressure. A lot of your Pacinian corpuscles are all over your body. And if you look at the dermis, they're going to be kind of deep, okay? So they're going to be deep in the dermis. So think you have to push hard, so deep pressure allows those to fire, so deep pressure. The Meissner's corpuscles, these are going to be in thick skin. Think about your palms of your fingers or palms of your hands. I actually like to think of Braille when I think about Meissner's. You find them just the very right in the papillary layer of the dermis, right below the epidermis in thick skin, so it allows you that fine discriminatory touch. You have nociceptors, which are pain receptors, and you have thermoreceptors for temperature. Lots of collagen fibers, so skin's very strong. These are some of the things that start to break down. Elastic and collagen fibers start to break down as we age, and we'll talk a little bit about that later on. So your elastic fibers obviously allow for recoil properties. So you have both of those in your dermis. This is a picture of your fingerprints, and so your fingerprints are actually called friction ridges, okay? And so your epidermal ridges lie just above that dermal papillary ridge. So that papilla of the dermis is what gives you your fingerprints, okay? And you can actually see the little sweat glands. These are the openings to all the sweat glands that you're looking at when you're looking at this fingerprint. All right, then lastly we have your subcutaneous layer, and that's made up of the hypodermis. And it's made up of, I'm not sure why that's doing that. That's kind of crazy. So we have our hypodermis, which is below the dermis, and it's made up of areolar connective tissue, which means that's what's connecting the dermis to the underlying tissue. It also has adipose tissue, and so the areolar connective tissue is like the glue, kind of holds everything together. Whereas the adipose tissue we use for insulation and energy storage and protection. Okay, so fat, obviously think about a bear hibernating. They're using that fat to insulate them and store up their energy so they can sleep all winter long. And then of course if you fall, you're going to wish you had some fat pads, right, to help protect you. So fat is very protective. And also your blood vessels are here. Okay, so if you're big, the bigger the blood vessels are going to be in the hypodermis. You have some small ones going up in the dermis, but the bigger ones are in the hypodermis. So if you get a subcutaneous or hypodermic needle, it's going to go in, and the medicine can get down into that blood vessel layer. All right, so that's all I'm going to talk about today, and I will see you in the next video. Thank you.